if you're watching this in the future. Today we will do some more work on the UI here. I've been doing some testing here, and we will do some small adjustments. Some small adjustments, and yeah, then we will start on the process of making this scrollable if we have overflow, but first we need to adjust stuff so that it works as intended. So I'll start with the button here. If we have a size here, we'll disable that. Let's see. And we want some text size calculations here. Let's see, maybe we want to change this function so that it calculates the max size no matter what. Because right now we will potentially have a null. Let's see, calculate text size. Okay, if we set this to float max here, and we store our index out of bounds. Well, we don't need to store our index out of bounds here because we won't use it. Maybe we just want some arbitrary value here, but so the idea should be okay, let's try a different function here. We will create a version that calculate text size, and we will calculate maxed text size and x restrict, and then we'll have a vec2 pointer out restricted size, which will be null pointer. And let's create that. So we basically use the same function here, calculate max text size. Where are we inside of this scope here? Let's see, blah, blah, blah. Now we need to improve on that later, so let's not close that one. We want it here, and we will basically copy this, except we won't break here. We will only update these functions here if out max or restricted. What did we call it? It didn't restricted size. And we will return our X here. And if our out restricted size here is set, we will set our restricted size to a vec2, which will have our calc max size, and 48 times our times our scaling factor here. Hello, buddy. Welcome. How are you doing? I'm doing pretty good. Hello, man. Welcome. So we can now, oh, whoops. Well, yeah, it only, there we go. So now we both are able to get our restricted size and our max size. So let's close this and close this. We probably are doing fine here. Create render data. I don't think we need that one. So inside our button function here, calculate max text size, and we want to set a vec2 restricted text size. And give it a pointer to that. That's nice to hear, man. Let's see. Let's access our window. Clipping area. Is that where we... yeah, we set our clipping area here. Maximum X minus R minimum X. So we constricted true and the window clipping area. So we now get the maximum size. We also get the restricted size. If the we will use the restricted size. For that, for now, we can always do computations on how big the button should be. Let's see how this works out. Okay, now we have buttons that snap around our text here. Which is pretty great. We also have a border. Yeah, we could add some padding and so forth, but yeah. Okay. We can also, well, we should be able to specify a button size depending on the initial R size specification, but we won't do that for now. This is fine. Eventually we also need to do some padding, but we don't care about that right now. Let's see. So we have our calculate text size and our there we go. And then we want to update our cursor here. Let's see. And we want oh, we already have a max position actually. We just don't use it. So let's frame data cursor max position dot x is equal to std max float The coordinates. What are you in particular referring to? It's inside the window itself that we are operating. So it's the whole viewport of the application. If that makes any sense. So we need to store either our X position here or our new cursor position. We will do the same thing for our Y. And thereby we update our draw cursor positioning. And we can always do some performance optimizations here. Speed of std max C++. Let's see. Yeah, maybe we want to look into some performance optimizations down the road, but we will update our cursor here. And we have our text field here, which will add some text size here. Okay. We updated this. Hello, buddy. Welcome. And now we need to do some calculations. If it's the first frame, we need to calculate the size of this window here so that we can potentially move towards scrolling. Let me just move the context here. I have to do it manually because I haven't implemented any drag and drop. I'm not sure whether that's needed as well, but let's see. That's probably better. I know the glyphs are not right. I think I need to resize the texture as well. Also, I would like to swap to a different font, so I'll work on that in the future. I already implemented the Georgia font instead. I find that it looks a bit better than the Comic Sans that our viewers here decided that I should implement. Hopefully Further down the line, someone will vote on a font change because the Comic Sans font is really ugly. Anyway, it's just the way it is. Do I actually, when I load the font, do I store the actual size? Yeah, I do store the size. Okay. Anyway, so we add our stuff here, and then we want to calculate some information on the let's update the size stuff. I have a plan here on my notepad. Let's see. We want to calculate the current size for this frame, and we simply do that by accessing our information here. So let's see. Let's specify a current size, which we will calculate from our window. Maybe I just want to rename this. I don't want current window. I just want window. Because that's what we're working with. And it's a local variable. So let's just change this. I don't want to type current window every time because we're working with this window. That's what this function does. It sets the current window because it's recording the actual window information here. Yeah, it might be too big. Then upload it to YouTube and create it as a hidden video. Then you can just send me the link. Okay, let's see. We will subtract our frame data, cursor max position, x. Well, this will be two components. Let's just create it like this. Current size dot x equals this minus our start position. Oh, we need a start position as well. Yeah, of course. Where did we declare that? Okay, cursor position, vector2, cursor start position, which will be 0 initialized. And we will set that when we set up the information here. We set that to our rect minimum here. I'm not sure what you mean. I'm unsure what you mean, OpenGL. What do you mean by text line edit or text editor? Let's see, cursor start position here. We should probably not reset this beforehand because, yeah. This will probably give us a glitch for the first frame. Everything will look weird eventually, but it will only be one frame. Let's see, because this is recorded once per frame, then it's reset. We should probably also set the max position here to whatever this is. Well, isn't it just because YouTube needs to do some processing? So the first time this runs through, everything will be 0, and um, this will give us a current size of 0, which I guess is all right. Let's do a maybe a content size is better. Here, better. Content size ideal. Maybe. No. We don't need that, I think. Let's see. We don't need that. I think. Okay. Let's see. I'm right now I'm trying to calculate. Let me show you. I created this window here, and I created elements on the window. And right now I am on a frame basis trying to calculate how big is this content inside of this window, and is it bigger than the actual allowed size of the window? Because if it is that, I need to make a scroll bar so I can scroll. That's the idea of everything here. Does that make sense? And our cursor is updated every time we add an element. The first time the window is created, it of course it doesn't have a cursor because nothing has been drawn to the window, but each for the frame number 2, all of these functions here have moved the draw cursor in terms of the X and Y, and we will be able to know how big our content size is. For each frame, we of course want to reset our cursor so that we can redraw our window slash viewport or whatever. Thanks for the link, Mr. Yes. I will watch it soon. Let's see. Let's see. So I need to calculate the information here. We will probably have a glitch of some kind which we can fix, but we won't care right now. We will add a scroll bar to our window. Let's see, where should we put it? Clipping area. This is frame data. This is item handles. Let's move this. I think I need to redo this as well, but position. Yeah, let's do some viewport information here. Let's do a float scroll bar Y size. And during our processing here, uh, during our processing here, we will set last. No. Let's see. Hello, Kumar. Let's see. Uh, Let's see. We will set a size. For the window here. We want to control, add the possibility of collapsing. So we want a size parameter here. Width and height, well, width and height, well, goddamn Vulkan. I have my fingers crossed that you will fix it today. All right, let's see. Our size is related to our, let's see. Let's see, what did I specify in my plan here? What did I specify in my plan here? We have our content size here. Do we actually store it? I think we need to store it as well. Yeah, I think we should store it. Let's see. How should I store it? Hello! Welcome to everyone. Yeah, I should store the content size here. Yeah, let's do that. The clipping area, the content size here. Let's set our window, whoops, content size.x to this. Our window, content size.y to this. And let's remove this. Okay, we have our content size specification, which is calculated for whatever we want to draw. We might add to the cursor here for drawing objects, since it's recalculate draw cursor happens every time we create an object, but the object doesn't get drawn if it's not in the clipping area. So even though that we calculate the stuff kind of like required to draw, we might not end up drawing it. So this means that our content size here is based on the actual content size, but not what is shown on the screen. Uh, uh, all right. And as I've mentioned, this will probably glitch a bit. So um, we need to calculate our needed size compared to what we actually have of a viewport slash inner size. And a clipping rect here up here. The clipping rect is the total area that is allowed to draw to. So let's see. Let's calculate float y span last frame, which will be our window clipping area y. Oh, wait a minute. It will be in pixels, of course, so we need to calculate it. Uh, um, it will be this max y minus this. So this is what was available. Y span shown last frame. I know it's a weird name. The problem with the chat is that I'm using Restream to both stream on Twitch and YouTube. So the chat has a delay because of the Restream. I was considering doing individual YouTube and Twitch chats. Maybe that would be a nice suggestion, or rather a nice update. Let me see. Whoops, this is an overlay. Let me see. I could do something like this. Let me just work a bit on it. Paste a reference here, and then I can do a setup here. If you find this annoying, I'll just mess around with the stream here. I just need to set it up every time, but I guess that's fine. Okay, let's swap this so that we get a live message. Let's, well, I don't know why it, sign into chat. Oh my God. Well, the problem is that the chat here does end up looking really bad. Can I clip it a bit? Well, yeah, it sends fast now, but it looks really bad. Would you guys prefer that I do it like this instead? Let me see. And then I'll have a chat feedback loop up here maybe. Whoops. Uh, mm, maybe a chat log. No, it's not an open source project. It's my source code, but so yeah, I haven't shared it anywhere. I'm building everything from scratch, and if I were to supply the source code, I think, yeah, well, I'd have to consider that. So I don't know the YouTube chat here. Let's see. Can I interact some way? Sign into chat. Let me see. Maybe I can fix the massive. Okay, I'll hide it here. I can't. The browser is really, really bad. Annoying. It doesn't allow me to do browsing here. Okay, OBS is messy, so I won't be, whoops. Interact. Well, let's refresh the cache. Oh my God, now it's just broken. Let's see. Okay, now we're back. Hello, welcome. Okay. Yeah, right now I can't fix the OBS slash YouTube stuff here. Can I remove this by pressing learn more? Well, oh well, I'll work on it later. Now you have well, as you might be able to see, my primary audience is on YouTube, so yeah, they get some special treatment. Okay. I'm gonna mess around with the stream stuff. In terms of the open source stuff, I don't want to get other people's help, so um, I will build all the code myself for this project, and yeah, that's the problem with YouTube. Yeah, I can imagine. So right now, this is last frame visible area Y. Let's specify that. Then we want some needed size for content Y, which will be our, you guessed it, content size up here. There we go. And now we have a difference. Uh, uh, yeah, good luck, buddy. See you around. So we will calculate the size here. And scroll bar size Y, because we're only using Y scrollers. I don't care for X scrollers. I would rather clip the content. So we will set it to our last frame visibility area. We also probably want a flag to let us know if we could just, well, we could just check for the size, but maybe we want to store a previous size and so forth. So let's change the name of this because it does not follow the naming convention. Well, we will add a scroll bar Y, which we will set to false. And we will set that flag on our window here. Scroll bar Y to needed size for content Y was larger than our visible area, or rather our size, which is our size here. Maybe we want to do manipulations on the scroll bar size. Yeah, there we go. So now we set a flag, and then we want to set our actual window. Scroll bar size to if we have a scroll bar Y, then we want to set it to a kind of like predetermined size, otherwise we will set it to 0. Yeah, Unity is a nice engine, disregarding all the problems around their monetization plan and everything. But yeah, I would definitely consider using the Unity engine. If I were to do a project that was in an engine. Yeah, I like Unreal Engine 5 as well. Okay. Next, we probably want to do some more recalculation. We have the content size, we have the clipping area. We have our size here. Actually created. And then we reset our stuff here at the end of the frame. Okay. Let's see if we can actually reach a state where the system tells us scroll bar require. Oops. That was what I was thinking. Reached state. Let's print out that. Let's change to debug mode so that we can do hard reloading here. Okay, right now we do not reach this state, of course. Inside our application, we will enable some more text here. Maybe a lot more text. Let's try that. Right now we should see overflow. We reach the state when we have overflow, so that's great. Okay. So now we at least know that our scroll bar is needed. Hmm. So right now we have a total window size here, which does not differ from our internal window size. But if we add the scroll bar, this would eat up our scroll bar size, so or rather window size, so that the visible area would be less. So let's see, let's do a rect inner clipping area, which we will recalculate here. If we want a scroll bar, we will do one thing. If not, we will simply set it to our previous rect here. So inner rect clipping area will be set to our clipping area. Otherwise, our inner clipping area minimum y will be set to our, no, yeah, well, this will still be the same. We could do border calculations on this stuff, but yeah, the y will be the same, both for the minimum and maximum, because we are not changing that. Whoops, maximum here. And let's do them in order so that we try to start with the minimum. But the minimum x here will be our, right now, do we hard code? No, we don't. Okay. Let me see how you guys doing. Okay, you're just hanging out talking about games. Good stuff, good stuff. Okay. So the minimum is, of course, we aren't going to use a scroll bar at our left side, we will create it on the right side. So that means that our minimum for the X will be, well, we could basically just, well, it will be the same copying. Anyway, inner clipping area maximum X will be equal to this, but minus maybe 20 pixels or something. Hard-coded size of scroll bar. All right. Maybe we want to use the inner clipping area here for this calculation here. We can check if need to use the inner clipping area instead. Let's see. Let's see. We calculate our content size. Do we need to recalculate our sizes here? Yeah. Here we can manipulate the size if we collapse the window, otherwise it will be the full rect. Yeah, so we calculate, this is our size specifier. Let me just see, I might have a pet that needs some attention here. Excuse me for just a moment. All right. And yeah, there we go. the maximum scrollable value can be calculated now. Let's set this flag as the first one. It makes more sense. Max scroll Y. So we will calculate that. As well. Max scroll Y, which will be the max of whatever. Huh? Content size Y minus, let's see, let's put this in a parenthesis so that we can let it know that this is an expression. And then we of course want the content size minus the inner clipping area maximum Y minus the inner clipping area minimum Y. This will be our needed scroll size. All right, great stuff. We need to handle some scrolling. Let's see. Let's see. Let's see. Didn't I specify that? Let's see here. Nope. Max scroll y is a value that tells us uh, how much difference there is in the um, um, uh, content pixels compared to the visible area. So for instance, if we want to draw content with approximately um, uh, maybe 100 pixels on the y-axis, max scroll y is that kind of like leftover amount of pixels that 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 needs to be or could be drawn by using the scroll bar. Does that make sense? Let's see, probably in here. Okay. Now we want to submit it to our renderer. Uh, so we want to calculate the bounding vol scroll bar. Hmm. We want to calculate our bounding volume scroll bar here. Which will be our, we will set the minimum x to be, well, the inner clipping area. Where is it? No, we can just set it to our clipping area minimum. No, maximum. We want it. We can just set it like this. Well, which means that we can just copy this value. Okay, that's easier. And we want the maximum to be our window clipping area, which is our maybe we should rename this to size. Maybe it's confusing. Okay, we will set it to size and update wherever we need. And then we will actually use this because this was the visible area. Now, this would perpetuate in terms of if we ended up in a situation where, yeah, this was would just gradually decrease over frames. We need some scroll bar offset thingy to fix it. Let's whoops, do this for now so that we can look up our. Maybe I actually do want to change this into our inner clipping area instead, because that makes more sense. The inner clipping area, I think when we want to add an item, does it overlap with the inner clipping area is the correct way to go. Instead, because let's see. Okay, where is the other error? Is it in text here? Or in button? It's in the button. Yeah, okay. Let's see. Does everything still work or are we... everything will still work. Okay. So our maximum will be our window size, maximum X here, and our Y positions will just be our, let's see, Y will just be our Y. So this is our bounding volume for our scroll bar. We will create it out here. Okay. Okay. Let's see. We want to add a frame here. So uh, we will add a background here with this function that let's close this. So we add a rect to our window, rect window, bounding volume, color border. We don't want to do that, so add draw rect window, and we pass in our context here. We pass in our bounding volume scroll bar, and we set it to, this is the background, so scroll BG color, let's set it to something like black so it will stand out right now. Scroll bar background color, and we don't want it to be bordered because we will create the bordering itself. Let's try doing that. Okay, the ordering here is probably wrong. At least that's what I think. Let's see. Do we end up in this situation? Let's see. The bounding box of the scroll bar. So yeah. Let's see. Window size 305. Yeah, so it does extend correctly. Let's see our draw calls here. Window draw rects. It now has a specification here. Well, doesn't it? Oh, I don't think I added support for non-bordered stuff. Yeah, that's why. We will just do the draw here. Base, let's call it that. Base color will be our color here. Right, there we go. That was the problem. Okay. And we have a scroll bar. Background at least. Let's just disable this call. Let's try to remember the distance between this, because I just want to make sure that it writes it on top of it. Yeah, it does. It does write it on top of it. So this is the scroll bar background color. We also need to do some calculations on our actual scroll bar. So let's do that. Uh, and we need to yeah, we need to calculate the bar. So we will calculate we will know an offset between, or relationship between, the visible size area and the needed size area. So ratio will be the visible area divided by the needed size. And We of course want to calculate the maximum size bar, which will be our bounding volume maximum y minus the bounding volume minimum y. Let's change this into a scroll bar size, which will be our max size scroll bar times this ratio. All right. Uh, we will also create a rect for the bar rect. Scroll bar rect. Which will be computed somewhat like this. So let's just copy this as a starting point. The x and y, or rather the x's, will be exactly the same, but the y position here will be let's just start out with our minimum and then set it to maybe our minimum plus our scroll bar size. Let's test that out, or test that bar color. I'm not sure that this is absolutely correct, but let's see. Okay, we of course need to set it as a different color so that we can see it. Let's just do white. Well, that is way too much. Let's see. If we do this, we still end up in a situation where we let's see. Let's just do something to test this. Oh, I'm so stupid. This might work because I need to change this, of course. I'm just overwriting the old other rect here. Yeah, okay. And let's add one here, and let's subtract one here, and let's add one here, and let's subtract one here. This will give us a border. There we go. Now we have a border. Yeah, I am. So this is our scroll bar. As we remove items from our program here, we should see the scroll bar decreasing in size. So let's try removing one item and hot reloading here. We see one item disappearing from the scroll bar. Let's do some more hot reloading here. Another one. And then even more. Well, the scroll bar disappeared now, but we have a problem in terms of the bounding volume calculations. I think we aren't rendering, or rather clipping correctly when we add the items. But at least that part worked. Yeah, let's check out the bug inside the clipping stuff here. Because right now it doesn't mean that it overflows, but it doesn't render the text. So there's probably a bug inside this function. Bounding volume, window add, inner clipping area. Well, I would actually like to step into this function right here and see what happens when we step into this. We don't care about the string constructor here, but let's see. We create a bounding volume here that should be within our actual scope of our context. We created it 500 pixels long, so it should just be at the border of the bottom border of the actual window. Okay, let's see. Let's see our cursor position here. Window, frame data. So, well, our cursor position doesn't. Oh, maybe it does. Let's see our size. Why? Well, maybe this is wrong. Our size. Vec2 size. Oh, this is not the correct value here. So it's 24 pixels high. Okay. So 24 pixels added to that. Yeah, we're probably not updating this correctly. We'll see though. Let's step into this. So our current, let's step into this. So we will have a ref container that is our clipping area. Which is 500 pixels large. This should be inside, so it should return true, which it does. Which it returns true. So it should be added. Yeah, we have a problem probably in terms of let's look up the draw calls here. So now we added a text draw call FPS. Well, the Y, X and Y position doesn't seem right, does it? Yeah. So let's redo it here. So for some reason, well, our position here is our cursor position, which we updated. Last frame, we calculate a size. We want to add something. Oh, there's a bug right here. There we go. Of course, we want to set the starting position to our X and Y, and then we want to add the X and Y components of our size here. Let's disable this. Everything should look better now. Yeah, okay. Great stuff. Pesky little bug. Let's try re-adding 2 elements here. Well, we now get a scroll bar that shows that we need to scroll to see the FPS stuff. And we need to scroll even more. Now, yeah, okay, great stuff. Everything works. Back to our scroll bar here. So now we add direct. We would like to add some button-like behavior to this. So we can use our isPressed function for our scroll bar rect here. How I draw it. I can show you the function to create it if you. We calculate the position from the cursor position, and then we calculate what is the maximum size of the text. By using the inner clipping area as a restriction, and if we need to restrict the size, we output the restricted size. Otherwise, we output the max size for the text, that is. We also, if we need to restrict the text size, we output the index of the character in the text. That is Yeah, the position is related to the cursor position, which is updated to the actual area of the window. It's in screen positions. We're working with pixels on this level. The renderer works in screen space, which is not pixels. Since it's a quote-unquote window that we create, um, yeah, my context is kind of like an item that decides a viewport. Meaning that it defines an area where you can create windows and widgets on. Um, it controls the max size and the position. Um, yeah, I'll add some functionality to move the actual context if needed later on, but right now I don't really care about that. Okay, let's do bool hovered equals false, bool pressed equals is, what did we call it? Not button. No, no, no. I won't be going into networking anytime soon. Um, I have no knowledge of network handling. Maybe if I really get far with this project, I'll look into networking. But yeah, right now we won't do that. Okay, so we set this to the scroll bar rect. Let's see, do we do handle checking? We should actually create a handle here. Also, let's see. Um, yeah, let's do a uint 64 handle, which will, what is the function called? Compute item handle, where we pass in the window ID, the item ID. Well, we don't care about that because we will cast this as an unsigned int. Scroll bar. Oh, we could just do uh, like this. Actually, I think this will be the same as an int, right? Nah, okay. I'm not gonna bother figuring that out. Scroll bar Y. So we will create our handle here. And we will pass in our handle. And we will store our hovered color here. We will move this because now we want to, if hovered, let's set it to a base color. And let's change the color if it's hovered. Let's just do a bit of dimming. Maybe we want a gray scroll bar instead, and then do highlighting when we actually hover it. That makes more sense, doesn't it? At least I think so. Hello. Okay, so if we hover the bar, as you can see here, it gets highlighted. Now we need to implement dragging it, of course, and calculating the scroll itself. But we want some offset to actually control our scroll bar here. Not only do we want some logic to actually control it, let's see how to do that. Mm. Uh, mm. Yeah, we need to add some logic to the scrolling itself. I need to figure out how to do that. Also, did we set a value here? Scroll. Let's do a current scroll. Um, okay. Okay. We should also probably move this down here. Oh no, we can't. Maybe we actually want to not pass in the scroll bar rec, but um, the bounding volume for it, because we would like to be able to kind of like click the scroll bar down here. So that makes more sense. No, I haven't had the time yet. I've been doing work on the scroll bar here for quite some time. Let's do a scroll ratio normalized 0, 0 to 1. Let's see. Window scroll. What did I call it? Current scroll. Maybe let's prefix it scroll Y. Let's do it like that, and let's do scroll Y max so that every value is prefaced. Scroll Y divided by window scroll Y max. Then if that is well, let's do something. Scroll ratio norm, which will be our scroll ratio lower than 0. Then we do a 0. Otherwise, we check if its scroll ratio is higher than 1. If it is, we select 1. Otherwise, we set it to the scroll ratio here. Oh, I'm sad to hear, man. Did you start over in terms of your components? Max scroll bar size. Bar pos offset normalized. R max scroll bar. What did we call it? My max size scroll bar minus R actual size scroll bar size. Divided by the max scroll bar size here. That should be our offsetted bar here in normalized space between 0 and 1. Bar offset normalized. Let's test that out. To the console. So right now we have no offset. Let's see if we know the height of this area is 500 pixels. So if I calculate set the scroll Y here to a 250, we should get a 0.5 here. Which we don't. 500. We don't. So 1000. Does it even change? No, I don't think so. Does it just stay the same value? No, it doesn't. Well, we have a problem here. And if we don't scroll, it shows us that information. If we target and let's do maybe 900. Well, we can't do that. Okay, we have a problem in terms of calculating the ratios. Okay. Scroll max. Let's see. I'll make a Doom slash Quake slash maybe Dark Forces 2 clone. When I get to the point where I can do faster iterations. Let's see. Mm. Thank you very much. Thanks for dropping by. It was nice to have you here. So let's dump out some information here because I need to see what we're calculating. Scroll ratio. Oh, whoops. Ratio. Scroll ratio normalized. Scroll ratio. Normalized. And I already dumped the so the bar offset normalized. One. Let's see. So our ratio is 0. Let's do maybe 25 pixels. Okay. Let's see the difference. Okay, normalized. We could clamp to 1. Let's see. Also, scrollable size. Y, of course. Uh, uh, the scrollable area was this value here. Okay, maybe I'm using the wrong values here because this is the scaling factor, which is the okay. Scroll bar Y is a flag. it's these two subtracted. The contents, of course, minus this. So let's see. We want to be able to scroll 52 pixels. So that's the maximum amount of scroll. Does this correspond to a value of 1 then? Scroll ratio normalized. Well, that actually is exactly how it's supposed to be. Yeah, that's usually a good way to do things when you get stuck. I find you will have code that makes it easy to redo stuff, but you will also quickly be able to iterate or redo parts that you've already done and that you are certain works as intended. Okay. So this actually works because let's do the. Did we ever calculate this anywhere? Needed size. Y. Max scroll pixels, which will y max scroll y pixels will be our calculation here. And we will make sure that it's either 0 or the actual value. Now we have that maximum scrollable size. This is related to the bounding volumes. This is related to the calculation of the actual scroll bar here. This is a temporary one that we set just for fun. I might consider it. I have a dream of doing a solo project that has a different direction than a 3D shooter. So when I get done with the prototype, I probably will do maybe a rework of the engine into something that is highly multi-threaded and then use that for a project. So the first iteration here serves as a yeah, kind of like you could call it a survey on how to do a game engine. So we have our max scrollable pixels here, which we will use instead. It will probably be the same. And then we will, of course, check if this is below 0, we will clamp it to 0. Otherwise, if it's above 0, we will check if it's above 1. If it is, we will set it to 1, or otherwise we will use the value here. Then we want to use that normalized ratio. Let's see, max size scroll bar. Which is our height. Okay, I think maybe this does work. Let's see, where did we end up creating an error? Did we need a parenthesis here? Or we just supplied one too many? Um, uh, I just have a problem with the way that we calculate that. And if we set this yeah. Okay. So we need that to update our position here. So right here, we can actually move this because now we are using the info here. We use this, we set the color, we can recalculate the stuff here. This is the initial position here that we will calculate from some interpolation between the minimum that y the maximum that y and then our bar offset normalized. So it will be minimum.y plus maximum.y minus minimum.y times the bar offset. Okay. Plus 1. So let's replace this. So it will be the minimum plus the maximum minus the minimum times our bar offset normalized. And then plus 1 in the end. Let's see. We need to parenthesize that. Okay. And then the x's are not that interesting. Maybe this shouldn't be. No. Yeah, that should be it. And this should be the same because it's the actual offset, but we have a pixelated offset as well, which is our scroll bar size here, which is what we did before. Wait, let's try checking this out. So the scroll bar is now at the bottom. Let's do 26 because it's halfway through. Well, it's in the middle and well, it should be at the top now. Okay, it is. Let's not print that to the console. Okay. Uh, okay, okay, okay. So now we have our dynamically updated thing here. Do we set our hover handle here? Okay. Mm. Let me see. Mm. Next, we will look into creating some stuff here in terms of holding it. Let's see. Yeah. Mm. So whenever we press it, uh, 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 hmm, okay. We do as we do here. If we hover it, and we clicked it, let's see. uh, uh, uh. Okay. Uh, and here we make sure that we have a release. Uh, Okay. Okay, let's try implementing a held function here, which will be false per default. But if we see that our current active handle inside our context is equal to our handle, mm, let's see. Let's see. Uh, we need to do some extra parsing here. Not only do we need a context active handle, we also need a bool active handle just activated, which will be false per default. We want to store some information. We would also be interested in a bool active handle is alive, or rather a handle. Okay, and let's update these flags. If the handle is equal to, of course we need to do this last, but if the handle is unequal to that, we set a flag that active handle just activated. We want all this to happen only if the handle is actually anything here. Otherwise we don't care. Equals true. can simply set this as this. There we go. Let's do, if we are actually experiencing a new handle by this activation here. Maybe we want to evaluate this in the same thing here. Well, then we set the state here. We update the handle. We could imagine a button that had an ID 0. So if we have a handle here, we can set RP context alive here. All right. So now we can check, well, do we actually have a handle? Okay. If the active handle Uh, is set. Okay, well, we simply want to ask, is our mouse button being held down? We will implement this in our uh, input system. Bool is mouse down, and we will give it a button index here. Where we simply will ask it, well, was it down this frame and was it down last frame? That would mean that we actually kind of like held it, at least for more than a frame. So it would be something different than a click. Okay. We can hold it for extremely short time, but we will simply set held to our input system here. Is mouse down, and we will ask for the 0, 1 here. We will expand this to be able to pass out a held parameter, which will maybe we want this to be optional. uh, let's see, let's do a pointer here so we can make that a null pointer here. Okay. And inside our function, of course, if we have a out held pointer, we will set the value of out held to be our held. This means that now our scroll bar here can ask, well, do we actually, let's see, bool held. Let's give it a reference to our held parameter here. So if we are being held, print holden, the bar. Let's try that. Well, it spams that, so we have a problem in our implementation here. Is it down? Was down. Was down. Okay, that's weird. Yeah, okay. We have the problem that okay. We don't reset the active handle, I think. Let's see. By just clicking somewhere, we're actually ending up in a state where let's print the handle. Maybe we need to reset it between frames. That is probably the problem. Handle. Inside our update here. Handle 0. Well, okay, we have some hover handle and handle. We have some problem here because I'm pretty sure this is not a correct state. Yeah, I'm pretty sure it's not a correct state. Okay, let's see. Is it hovering? Okay. Let's see. We get into this function immediately. Hovering, we don't. What is our handle here? Our active handle. Why does our active handle get set? And where does it get set? It's not getting set there, but we already have a active handle, right? No? No, we don't. Oh! What a silly mistake. Okay, I was simply assigning, and if that succeeds, I must be holding the object. Okay, never mind. The program will do whatever you ask it to do. Okay, right now our health doesn't really get procced. So can we ever get into a state where here Does the... No. So if I try to like... Oh, the problem is that we are simply... No, we should be saving the state right when we save frame state. Let's see inside this. This frame state, last frame state. So this will not result in, well. We could simply ask it if our mouse button is down this frame. But I would prefer mouse button released, get release position is clicked. This is when we have a change. I mean, it should simply keep the state, right? Let's see, mouse key, save key, frame state, last mouse state, this mouse state. So it will, if it was clicked, oh, only when I release. Is this due to the way that the application handles the processing? Let's see. Uh, okay, let's check the input just as a debugger here. Let's see. Let me and only do it for button 0 here. When I hold it, it should be 1, as you can see here. Save frame state. Maybe the call to save frame state is coming too late in our application here. Running. Handle messages. Let's see. Run. Maybe we want to save frame state. Then on update, what do we do? UI system. Controller. Yeah, maybe we want to do it in that order. Well, we still can't get anything to work correctly. Let's see. Is mouse down? Is it because I do some weird reset somewhere? Let's see, do I end up in processing this all the time? Frame? No, that I don't. So it's not that it's resetting that. Ah, that's weird. That is pretty weird. And as we saw, we should have the same state, but why doesn't it? Let's do a check here. It only updates that. And if I do the print again, and add the print again. So here, did I change it? This frame state was down. This should be true. I don't know why it's not true. That will grab the click. That will grab the release. I mean, this should be. And it starts out with that state there. I don't know why it's possible to end up in such a state. I mean, if we add the frame statement again. Is it the ordering? Yeah, I'm sad to hear, man. Let's just swap this. Can I ever get into a state where... We can't simply do it. I mean, it updates here. We could also do the old time test where the thing here needs to be down, and then we need an 0 amount of changes. This will be basically the same. I don't know why the other thing doesn't work as intended. Some weird bug where the state doesn't get copied correctly. Anyway. For some reason, it doesn't seem like this evaluates to true. And let's see. Saved state. Congratulations, man. What was the problem? Maybe this is actually... no. Do I reset it somewhere? Is there a reset somewhere? Because let's see, we do not call this all the time, right? Called created input system. We shouldn't be calling this more than once. Ah, yeah, okay. Saved state. Let's see the old. New. That's just programming. I can't get this to do what I want. For some reason, the states are not registered correctly. Let's see, do we have a weird point where they are not equal? No, they're always equal. When we call the save state, let's try this function here. Old state, new state. As you can see here, the old slash new state here. For some reason, it doesn't register correctly when I call this function. Do I have a weird assign somewhere? Do I have a weird assign somewhere? I might have a weird assign. Was button released. This mouse button down. This is the old one. Yeah, I don't know what it is, but let's check for assigns here. Okay, this is not an assign. This does not contain an assign. Not this one either. Not this one. No weird assigns so far. So that's not it. I shouldn't be in a state where, I mean, the application now calls it beforehand. Oh, maybe I need to handle messages first in case something gets sent. Or what? Now nothing happens, right? Uh, Did I just disable everything? Well, that is weird. Because, let's see, do I do something weird in here? I process the states and translate the messages, which should update the states. But then on the create function, I don't need to do anything. We handle our messages, we save our frame state, which should be all right. But for some reason I can't do any input polling here. Let's just do a test. If input, whoops, input system is mouse clicked, one, print, did it. Let's see, we check for this frame state was down. No, not down, if it was released this time. So let's see. For some odd reason here, okay, maybe we're saving our state or handling our state here in this will be, yeah, I think we need to change this algorithm again because I think we created a input system where there were some bugs that were not supposed to be there. So now if we check for the click here, we want to see that it actually changed state. It wasn't down and it changed state. Now this should work okay, right? Nothing works. Is mouse clicked? Is it? Yeah, it's. Let's see. Do we process our stuff here? Changed. Let's reload that. Changed. Okay, so we do create some change. Let's see. Mouse state is down. Let's just get that. Yeah, we do get the correct changes here. Well, let's see, and we check for is mouse clicked. What if we check for this instead? That doesn't matter. Is it static? It is static. The memory location is not static. Is that a problem? Let's try stepping into the function. Let's close this, close this, close this. Also this. I want to check for this. Okay. The instance here list. Oh, maybe. Maybe. Let's try something different here. Let's do something here. I think this update algorithm might be wrong. And that's probably what we're working with here. Let's see. Because it doesn't know how much memory to copy, because it's just a pointer, so the first object here will just be set like that. So, okay, we copy the was down function. We also copy the num changed, and then we reset it for the frame. Let's try doing that instead as an update here. Let's try getting some information from our program now. Changed at least works. Well, we don't care about the changed anymore because we know that works. Our application checks for that. Let's see. Let's just check if the mouse button was down. Now we did it. Okay. Oh, the problem is that we now overwrite our counters. So let's move this back again. The problem is that we override our counters. We don't want to do that. We update our input here. We store our information in our input set. And we reset the number of state changes. We only update this whenever we process some information. Let's see if this changed anything. Is mouse button down? Well, that's the old one. Was mouse button released? Let's try testing for that one. Yeah, so a click results in that. Let's see. What did we want to test? We wanted to test was mouse button released. Now that works. So is mouse button down is just a basic check. Is it down? We don't care about how long. Was it released? It seems to be working fine. And this hasn't been changed. Is mouse clicked? What did we try to do back in the day? We tried to do like this. Is mouse clicked? Yeah, it was definitely clicked and it registers on release. His mouse down is our new function here. And we actually would like to be more than okay, it does the check now, which we don't want. And let's see. Now it really does work. Maybe if we let's just do the last mouse state. If it were down for several frames, since yeah, let's see, and we did some input polling somewhere. Holding that bar here, that's fine. Let's try doing this. Well, that's not working. Okay. For some reason it doesn't. Oh! Maybe. Yeah, now it works. So the problem was the way that I copied the state. I was probably just overwriting parts of the first values. Mouse button down. Let's call it multiple times 2x, because it's several frames. I mean, you could argue why even why well, oh, it's because it's not declared in the correct scope here. Let's see. And then we want. All right. We need to delete this. We don't need it anymore. Let's see. Okay, we should be able to click our scroll bar. Okay, it doesn't register anything yet. So there's probably some problem. Let's see, enter check. Enter check does fire. Also this one, but the held doesn't result in anything. Let's see. Let's just check this. Oh, we probably. No, wait. Let's just see. Held. No. So this function here. Oh. We want the last. Well, this should just return true no matter what. Okay, maybe we made a mistake. Is mouse button down? Was mouse button released last? Number of changes is this frame state. Is mouse click last frame state? Okay. Let's try checking for this because it would mean okay. For some reason we run into the same problem again. If this just evaluates, we should just get a true. Well, we're not even getting a true on that. Why is that? This frame mouse state. How can that be not? Is mouse button down? Is it? If we change this function to this, for some reason we have a problem. Maybe, let's see. We want to get a message every time this is handled. Right button up, down. Sys key up, down. Tester. We only process it once. So how come tester 1, 0, 1, 0. So this should basically set the mouse state here. Correctly, which it usually does, but for some reason it doesn't want to. For some reason, somewhere we invalidate the state. Let's swap it back to this because that's what I'm testing. So I was down. Clicked works fine. But this doesn't for some reason. We process the input. Mm. And we do enter this case. Yeah, we will do that by polling. So there's no need to check for that. If it wasn't down, let's see. Yeah, so whenever I release it, it works. So it does register. Okay, so let's think about this. So the input gets set. Let's see. Process. And let's do a check in the copy here. If this mouse state 0, false flag. So we set a false flag. Process. We stop setting false flags, and we start setting false flags. So it does register that this is being clicked. Oh, maybe we can't end up in a state where because it worked outside of the scope. I think I know what the problem is now. It's because whenever I actually click the button, I require and release. And on a release, it can't be yeah. So print set state. Let's see. So I need to click before set state gets called. So that's the problem. Okay. So it can't be down when I click. So if I click, I can't hold. So that's the problem. Finally, I figured it out. Let's see. Okay. Uh, so our scroll bar here should actually have some different behavior. So our scroll bar right now, a button works fine with the click and release, but we can't get the pressed while we get the held here. Uh, so how do we fix that problem? Mm, So that's a problem. So let me try to fix that. Huh. Um, well, we could try to end up in a situation where we keep the active thing alive, but we won't set the active state before we release. But maybe that makes sense. For instance, if we click and release it. But, well, Huh. Mm. Okay. Mm, 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 mm. Set active ID. Let's see. Inside our check here. Is item pressed? Will we simply print out this tester whenever we have set it? No. So we can end up in a state here where our active ID here is being set. Uh, Uh, let's see, maybe I should do a break soon. Mm, mm, uh, uh, s- well, mm, let's see. If our active handle equals this on this check, we are active. Oh, whoops. Yeah, I didn't realize that my headset turned off. It usually does that from time to time because of an, I don't know why actually. It's a bug in the headset. Yeah, so I've been blabbering on in silence. Sorry about that. But I'll review the engine whenever I do a break, or maybe when I'm done with this project here. So, yeah. Okay. Let's see. Uh, and we do a check inside our update stuff here. Where we simply check here. Mm, If the active handle here is unlike 0, and if the active handle alive is unlike our current active ID, then we want to call uh, we want to clear our active handle. We want to of course clear this. Do we have any other flags? Context, second. Set this to false. Okay, now we can actually keep something alive here. Well, yeah, in general, you'd like to you would like to align things in terms of whatever is going to be handled on the GPU. I think the byte alignment might be larger on most hardware vendors. I can't remember, but thinking in terms of 128 bits are probably pretty good, which is probably 16 bytes, isn't it? Yeah, I think it is. Uh, got the DirectX 11 API, so yeah. Okay, let's see. So let's do a call here, reset active handle. Yeah, yeah, so 16 byte alignment is probably the way to go. Let's see our update here. Am I doing this correctly? If this handle is not 0, let's set this to 0 here. Outside. Just activate it. Also outside. We only need to reset the handle itself here. Let's see, do we have other active handle stuff? No. Why would it reset that? I mean, whenever, let's close the record window for now and record. Let's see. Trainer kept alive. Should be. Oh, we don't reach that state for some reason. When we click it, Uh, let, well, is this not, this is not, this is a bool active handle. There we go, there's a bug. Hi man, welcome. Yeah, there is a performance penalty if you don't byte align stuff. You need to do that. Okay, we're keeping it alive, kept alive. Okay, great stuff. Now we're um, now we're doing stuff correctly. So there were some bugs, some small bugs. Okay. Let's enter check. Let's check our UI stuff here. We don't care about that. Process doesn't matter. Let's see. Tester 1. It's probably inside our UI state here. Created input system. Is it? No, it's not during the save. 1, 2, 1, 2. Enter check. It's not here. How do I call that print? Oh, there we go. Okay. Oh, wait a minute, wait a minute, wait a minute. I know why. It's because our scroll bar doesn't. Uh, we don't need that. Our scroll bar here doesn't keep anything alive. Um, window add item. We don't care about what it returns, but we will care about the stuff that it handles. So, okay. Okay. We can simply use this piece of code here inside our scroll bar stuff. Let's see. We do it inside record window here. Holding that bar. Let's see, let's keep it alive. So now we are holding that bar. Which is great because that's what we want to do. That's what we want to do. We want to do some processing here. Let's see, maybe we simply want to yeah, the first time I click it, it's really it doesn't respond at all. Yeah. Mm, okay, okay, okay. Uh, uh, mm, Maybe we want this then to be only our simple one here. I'm doing fine. Not now, at least. I think everything is all right. So when we click So I right now need to double click this thing and then well, that's maybe all right, I guess. It's a weird feature. I mean, our 2x here just returns true now. I prefer for it to work in a different way. I mean, now I click, now it's the active ID. Now I can click and drag, but I click. Yeah, yeah, but we could. We could change this if we wanted to. We could set. Okay. Okay, let's just try to process this. We will fix that minor issue later. Okay. Uh, we need some flag. Uh, Hello. Welcome. Good to see you. We are faring all right. At least I am. Um, okay, I'll just skip that damn bug. Mm. We also need to change this function here in the future. Let's store it inside the thing here, even though it's not nice. Let's see. We have a mouse position struct here. Get mouse position. Which we will implement, and we will simply use the code here and use that for now. It might be all right. Let's translate a position. X equals point X, position Y equals point Y, and let's return that. Now we can input mouse position, point equals to input system, get mouse position here. All right. Let's see. Okay, we're back to normal here. So we will pull the operating system. Get cursor position window. Maybe. Yeah, we can look into that function later on. But inside our stuff here, we will, if we are holding the bar, we will know the top position here, const float top position scroll bar. Which will be our bounding volume for our scroll bar here. Minimum Y. We will also store our mouse position Y. Let's do a Y as well. Input system get mouse position dot y. Uh, uh, uh. Let's see. We will. Uh, 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 uh. Mm, okay. Um, click position y equals our mouse position y minus our top position divided by our scroll bar size. And then we clamp this to a normalized value. Click pause y normalized equal to this. If it's lower than 0, then we set it to 0. If it's greater than 0, let's do the same syntax as before. We check if it's higher than 1. If it is, we set it to 1. Otherwise, we set it to this. So first off, is it higher than 0? If it is, we check if it's higher than 1. Let's see. If it's lower than 0, okay. We do 0, otherwise we check if it's higher than 1, then if it's higher than 1, we set it to 1. Hello, welcome. Okay. Okay. Let's calculate a scroll value. Which will be our normalized click position here. Minus our let's see, where did we store that? I think we stored it somewhere, right? Uh, mm, which is just our ratio between these. Mm, minus this divided by 2. I can't float ratio here. Let's just set this as a value here. Minus the ratio. Normalized. And the actual scroll max is stored up here, right? Max scroll pixels. So const float scroll value. This. Let's print that scroll value. Minus 250, 300. Okay. Well, this is probably able to run out of bounds fairly quickly. Yeah, as you can see, it escalates too quickly, so we need to pixels. Let's set this as a scroll thing normalized. Let's do the same thing here. There we go. Yeah. And let's translate that into pixels here. Yeah, so yeah, that works. That works. Okay. Let's set our window scroll y to our scroll value pixels here. And let's see. We will do our rendering here. we need to recalculate our bar offset here. Yeah, we will clean up this code eventually. The goal will be to get it to work. So up here, we will offset, update this value here. We will use our scroll value normalized. Here. There we go. So we will update that. Whenever we click it, yeah, as you can see here, we are now able to slide our, well, it's a bit funky, and it also gets rendered every time at a reset position, unless I hold it, because well, you didn't fix the 3D issues, or did you redo most of your engine stuff, or did you abandon it? Uh, let's see. Okay. Yeah, that sounds nice. But what are the 3D issues that you're having? So where did we end up? We ended up in a state where, well, uh, well, that sounds weird. Is it related to the indices? Maybe the indices are not set correctly. Also, if you're doing indexless rendering, you need way more vertices. Remember that. Then every face takes 6 vertices instead of 4. Okay, you don't have any index buffer. Well, are you sure that you have supplied the correct amount of vertices then? You need to supply 36 vertices for a cube without indices. As far as I remember, 6 faces times, yeah, 6 vertices per face. Well, it was just a suggestion. I don't need to check your data. Okay. Well, that seems totally normal, but you still need 36 vertices. For one cube, you have 36 vertices. at the early parts of the 3D program, it's perfectly normal to have a color information on a per vertex basis, I think. Uh, Are you sure you have the correct winding order for all your vertices? Yeah, maybe just download a OBJ loader or something and implement that and load a Blender model or something. That will rule out the problems being with your manual specification of the vertices. It might also be your draw call, I don't know. Oh yeah, well, then maybe you have depth buffering problems. Depth buffering or pixel shader problems then. Maybe you don't translate the correct values in the shaders. Or maybe you don't update your or maybe you don't update your colors. I don't know. Maybe depth buffering issues. If you seem, if that seems likely. Yeah, that might be as well. Maybe try transposing your matrix. It could be the ordering of the values inside your matrix. Okay, so when we update the let's see. Cursor start position. Y. No, cursor start position and cursor start position will be equal to erect minimum x here, and cursor start position y will be equal to erect minimum y. And minus our window scroll y. Let's set it like this instead. And let's see what happens. Oh, we have scrolling. Wouldn't you know? At least temporarily. It resets every frame. But that's an easy fix. Well, you could still you could still end up in a situation where the matrix was stored in memory wrong in terms of what the shaders expected. It's not API related. and it's your math library that you use for transposing matrices. It's not related to the Vulkan API. Let's see. We would like not to reset our scroll every frame. And thank you. It's going in the right direction. I'll soon do a break and grab some food, and then I'll create the list box that is needed to do well. Do the editor. It could also be your view projection matrices that aren't set up correct. Maybe you have the wrong near and far planes, or maybe you have depth issues on that regard. Maybe there could be all sorts of problems. Maybe your shader doesn't output the correct data. Yeah. You don't have any view projection matrices? Well, how do you render 3D then? You can't translate into clip space without view projection matrices. It's part of the whole 3D thing. But if you're using a custom engine, it probably does that under the hood. I don't know. Let's see. Mm, uh, equals to either this or this. Let's see, does this solve anything? Well, yeah, you have a transformation matrix that probably handles rotation and scaling, but you need some kind of way to tell the pixel shader slash fragment shader, as it's called, I think, Vulkan how your camera is set up, and that uses a view projection matrix. You can't create a 3D without any view projection matrix. You might have it as some default values, I don't know. Maybe um, you use some kind of program that provides that for you, but transforming the vertices by their transformation matrix just handles them in object space, or rather world space, but you need to transform from um, object slash world space into view space, and from view space into clip space, which is your screen space. Um, that's part of every 3D rendering process. And if you don't do that, you're not doing 3D, you're doing something else. Yeah, it's fine. The transformation translation matrix is fine, but you still need a view projection matrix that you need to translate the vertices with also inside your shader in order to get to a appropriate clip space. Remember, 3D is by taking 3D coordinates and actually translating them into 2D coordinates on the screen. Uh, for that, you need the transform for the actual object, and you need the view and projection matrix. Without those three matrices, you can't do 3D. At least not real 3D. You could, of course, do uh, other kinds of 3D. Okay. Why do I not store this correctly? The view frustum is actually the view projection, or rather the view matrix. The projection matrix is your depth of field and near and far plane. So the view frustum is made up of a combination of the view matrix and the projection matrix. Without a view frustum, you can't see anything, or at least not see anything correctly. I don't know. Uh, Maybe learn to program in um, in Pascal or something. Make a DOS program. Make your own operating system. Build a computer. I don't know. Uh, let's see. It wasn't for you. I was talking to Commodore on Twitch. So when I release this, I shouldn't be resetting here. Yeah. Now he was asking what to do if everything that he loved about tech was gone. Mm, maybe the position itself is. Let's see. Uh, because I'm just using the rect here. Well, Commodore, if you learn to program in a Pascal or assembly, um, it'll be plenty old school and no abstractions. It will just be you and the machine. Maybe salvage an old computer and build a operating system from scratch in just assembly. Yeah. Well, then just build the hardware itself. Maybe I saw guys on YouTube building a potato computer. I mean, just build the actual hardware then. Ah, well, if logic gates are too abstract for you, well, then there's no hope. I think the problem is that you don't know what you're really looking for and you aren't satisfied with any choices. You can still do that. You can even, I have a relative far out that builds basic components for everything from scratch. He just orders the PCBs from China and even puts them together himself. So who cares if it's a relic? If you enjoy it, do it. I'm I'm gonna restate what I just said. It doesn't seem like you actually want a uh, well, I wasn't no knowing that you were talking about a job. Well, times change. Doesn't seem likely that you can get a high salary on things that aren't relevant. Uh, so let me dump out the scroll Y. Yeah, just so I know. Uh, Scroll Y, because this probably resets. Scroll Y, as long as and when I release it, we're back to 0. So when does it get overwritten? Yeah, that sucks, man. But it can happen to all of us, so do the grieving and then move on and try to focus on something else. That's my best advice for you. It won't help you to get stuck in trying to force the current times to be different than they are. You can't control that. You can only control what you do yourself. Uh, what if I don't update the scroll Y? Mm. Well, I wasn't saying that it is supposed to end. Grieving never really does. That's an illusion. Oh, I reset it here. I did. I totally missed that. I actually did it manually. Whoops. Um, but you do eventually move on. There we go. Awesome. Our scroll bar here works. All right, awesome. Well, if you decide that that is the way that it's going to be, well, then yeah, you're right. If you made up your mind and are going to continue down on the path where you will keep on focusing on what you can't change and what you can't do, and well, yeah, nothing will change. It's your choice. I don't blame you. You can do whatever you want. I mean, it's all right. The logic is that every human goes through grieving and difficult times, myself included, and you just need to learn to handle how things change and how you react to them. Hello, long time no see, Alexis. How are you doing? That's great to hear. Well, let's just disagree on that one, Commodore. It's going quite alright. I'm adding some UI here and some functionality so I can build a level editor. I also completed the physics engine, so as you can see here, Paul, our good old friend, flies around the scene if we force him to. So it's going quite all right. The next thing I want to implement is a so-called list box. Why, thank you. I always knew I could count on you, Alexis. You've been here almost since square day one. So, but yeah, how's your computer control program going? To do new UI system, add text to the buttons. We haven't added alignment to the text, but it's a minor one. Do a list box implementation. Do scrolling. We already did that. Do some drag and drop stuff with the UI. We will do that. We will do open, close of UI, context, collapsed version of Windows. But we will do these things last because what's up next is the list box implementation. So yeah, I was considering doing a break of sorts since oh, interesting. Did you move country or did you just move out of your house or? Oh, okay. Are you using a game engine of sorts or how are you building the game? I mean, this is just awesome. Well, the scroll bar is still a bit funky. You need to activate it before you can actually scroll, but oh, okay. Well, it doesn't have to be released to be worthwhile. Let's see. Hmm. Okay, should we do a break here? Let me see. Well, that's a great start. Everything starts with the map. If you're doing, what do you call it? Tactic games. Did you decide on a square-based or a what is it called? What is that tile set? Hexagon-based. That sounds awesome, man. Okay, I'll be AFK for maybe half an hour. Let me see. That's nice, buddy. Good job. All right, I'll need to get some food and do some stuff before I continue on. I would definitely like to do the list box implementation so that this editor will pick up speed. I don't know. Let me check out what I have in my kitchen. I haven't decided yet. But I'll be AFK for maybe a half an hour. And yeah, I'll be back later. I've also been streaming for 6.5 hours without any breaks, so I think it's needed. Oh, thank you. That sounds nice. Thank you very much. See you guys later, hopefully. All right, let's see. Okay. All right, so we want to do some work on a list box implementation. Bool list box. Here we will take our context pointer, p context. We will take a string reference, temp/temporary. It will be our label, and then we will take a potential vec2 our size. There we go. Hello. Yeah, I'm back. Back again. Tell a friend. It was pretty fine. I also did some housework and talked a bit with the missus. So yeah, ready to do some more work on this marvelous UI. How you been doing? Let's set our window. Current window. Let's create a handle. Create a handle. Let's see. Compute item handle. Let's give it our window ID here. Let's give it a 0 item ID. And let's do something like underscore. No, let's just do the label. Let's see, string. Cast as a U, unsigned int. Const unsigned int. There we go. Great, man. Did you get your 3D stuff to work? Let's do a size calculation here. Let's just set the size here. Size X equals the p context. No, not p context, or window in a clipping area. Excuse me. Max.x minus the minimum x. Hello, welcome. Well, we also want some text. Let's see. Well, how does this actually differ from our other function, the one that are we using this for anything? Well, we might want to if we do future calculations. Mm. Uh, mm. Uh, let's see. So we want our size here for our list box, but we would also like our text. Maybe we just want to calculate text size and let's see, vec2 text size equals. Let me just copy the syntax. Yeah. And we will create a int here. So we calculate our text size here. Where this will actually be our text size dot x. And our y will be recalculated. Let's do 28 times this will give us a line height of 28, and then is did I swear? Oh my god. And since we're doing a list box here, we will create a size for the frame. Well, this is basically the same. Yeah. But we will calculate a bounding volume. For the frame, perhaps, and another for the headline. Header. Well, sometimes I don't know what I'm saying. So the minimum is supposed to be our window cursor position, frame data, cursor position. Our bounding volume frame here, maximum is supposed to be a vec2 with our window frame data cursor position dot x plus our size dot x, and then the same for our y here. Then we want to create a bounding volume for our header here. We should be able to draw our header without drawing the actual box itself. So the minimum value will be equal to the bounding volume minimum value. And we can just do the bounding volume maximum is equal to well, actually, this is not the header. We're calculating bounding volume whole instead, because this will include let's think. Okay. The size doesn't include the header size here. We set the X to the frame itself. Is equal to that. So this is probably the frame size. And we will let the text size here control how wide it is. Maybe. We will do that for now. But the whole thing will I mean, let's see. Maybe we just want this and then EY will be including the text size. .y. We'll see, we'll see. Yeah, it will be interesting to see if that solves your problem. Right now, I'm not sure that we actually want this. Mm. I'll view it probably tonight. You can send a video of the final result, sure. So the bounding volume. Yeah, I think this is fine. Uh, let's see. Mm, if So let's check if it's visible or not. If rex overlap our container here, let's see our inner clipping area and our bounding volume frame. Let's see, and we want to return false. We will do some calculations here. Let's see. How do we do on our button? We recalculate the cursor here. First time we draw it, it probably won't get drawn. Our p context here, and then our size. Let's maybe 2. Well, we do have our size here because we simply add it. So I think we can just pass in the frame size here and then be somewhat certain that we increase our cursor correctly. Then we want to add the item. So window add item. Our bounding volume frame here. And then since we're just creating a frame here, I don't think we need a handle per se. We will Yeah, we will mess around with this later on. So let's see. Oh, we aren't actually adding anything. Well, we definitely need to fix that. Yeah. So let's create some stuff here. We will create actually a new window, which we haven't done before. It will be a child window. So let's add that functionality here, because we want our frame to be scrollable. Therefore, we would like to use some of the same kind of logic as the let's see, const onside int id. Maybe not unsigned here, because maybe we want to be able to go negative. Then we want a UN64 handle. Maybe we created that. Then we want some R size. Let's try starting with that, and then end record window, child window. Const unsigned int id. Right now we don't care probably. Okay. Let's implement these two here. Where did they get created? Up here. Well, Window pointer parent window is equal to our context current window. Inside our window class here, or rather struct here, we can set a parent. We will have a size specification here. Okay. We have some size. Okay, maybe we can just use our this is a bit harder than I expected. Okay, so whenever we call record window here, if it's equal to the Windows array size, we will create a new window. Otherwise, we swap to the current window. We check if it's a new frame. Okay. So we would like some of this logic at least to be called. We wouldn't mind that uh, to be able to record some commands for our next window, so to speak, because we would like to control this. I mean, we would like to this is really never used. I should delete this. Because we want to create a new area with a scroll bar. So but we could also just record the child window with the same logic. Although I do think that it would be more elegant do it the other way. Okay. So let's see if we were to create a function here that so let's see our list box here. Our list box here would like yeah, let's just get something drawing here. So we calculate our handle. We calculate our text size within the bounds of the whole clipping area. We then calculate our frame size, which is the amount of elements times their height. This is the frame. The bounding volume is related to our cursor position plus the frame. But we would actually like a different bounding volume here, including the header total, where we will set the minimum to our bounding volume frame minimum here. We will set the maximum to our bounding volume frame. Let's see, maximum, but we only want the X to be that. We want the Y to be equal to the bounding volume Y plus our text size Y. Plus some spacing. And actually we want to check if this bounding volume here overlaps. And we want this to be a vec2. where our width is our bounding volume max x minus our bounding volume minimum x, and then our bounding volume max y, and minus our minimum y here. So that's the area that we want to add to our draw cursor. Let's see if we ever end up in a situation where we passed it. And let's do a list box here. UI system to list box, editor, label test box list, and our size will not be set. So this should, yeah, on the first pass through. Oh, what is? Okay, that's weird. That's a weird glitch. Once we get, okay, there's probably some value that doesn't translate well. So we will do some bounce checking. Oh, we passed it. Oh, that means that we actually ended up in a situation where we can see our bounding volume. Yeah, it's allowed to be drawn to the screen. That's why. Okay. Yeah, we will fix the glitches. Let's add that to fix scroll bar glitches, probable overflow of scroll range somewhere, plus let's change that it needs to be clicked plus release for it to scroll. There we go. We will fix that eventually. Okay, this means that the first time that we try to add our list box here, the rects won't overlap. But we will tell the underlying cursor system that we would like to add space for it inside the underlying window contents, or rather expand the underlying contents to include it, and then we will add it. Uh, since we're just adding a frame here, we will check if it's visible. And we will return true if it's not, or rather if it is. Okay, so we pass that place. Okay, and then we will call a let's see. Mm, yeah, let's start out with that. Let's see. So we pass in our handle here. Let's pass in something here that we will pass in our current window ID, p context. We will pass in our window ID here, and we will pass in our handle. And then we will pass in a size, which will be our well, it'll be our frame size. We want to create a window with a scroller on the side. Which will be the element size and the width of the whole thing. Okay. So we will call this, and we will need to fill out this. So for us to reuse some of this code up here, maybe we should do as some other people do it by creating a struct here, window frame data, struct window creation data. Where we can call clear. Where we will have a window pointer. Well, we need to. Oh, we've window here. Forward to clear that. Uh, mm, let's do something like bool child, which will be false, which also corresponds to right now we can set everything to 0. We don't want any particular values. All of this can also be 0'd out. Let's set some window handling, frame data, restrictions, window handling, current window, a series of windows. Next Windows ID, window ID is not what we use. And temp creation data, window creation data. This should not. Oh, okay. Context. Windows. That size. We don't need to increase that anymore. We want a size. Let's see. A big 2 size. So p context window creation data parent. This will usually be null. So now we can, if we call this function from our, let's set our context function. Window creation data. Parent will be our parent window here. So we have a predetermined size as well. And we want to calculate the unsigned int expected ID, new ID, which will be our context windows dot size. Let's see. Well, we kind of like just force an ID for this window here. Let's see. Okay. Uh, and then we should be able to actually just create our window here. Let's whenever we create a window, we will call p context create window data clear, because then we will clear whatever we need. Okay, and let's record a window. Let's see. We would like a. Let's see. We should created window, a new window ID. Let's just do that. And pass along the context, pass along the new ID. Let's see how that works. Oh, we just keep on. Right. We just keep on creating windows. Created Windows 0. As you can see here, everything is just messed up now. Uh, well, yeah, we have a problem. Okay, maybe we will use the handle. Maybe we will use the handle. Because this increases every time. So this is basically an infinite loop where we just keep on adding windows. Right now our system is not very sophisticated. Well, how do we handle that? No pun intended. We could add something like create we could add something like a uint64 handle here. And then the p context window creation data handle would be this handle here. We could create a function here where we, instead of a specific ID, actually we're allowed to specify a const uint64 handle which could be zeroed out per default. This is also const actually. Const uint64 handle. Let's see. Let's do an else if handle we probably want to do the same here, although the ID itself is iterative. Let's see, ID larger than or equal to 0. We do this, or else we simply return print an error creating appending windows in UI. Let's see, and let's add a new line here. Okay. So now we can ask our system to create a window with an invalidated ID, but with our handle here. I don't think we need to store the handle. Let's disable it for now. We might want to in the future, but created Windows 0. Well, why? Okay. Our handle here. Let's see. Okay, there's some bug somewhere. Oh, yeah. Okay. Now, that is exactly what we need. We just didn't realize that we needed it. If the handle is equal to our p context create window data handle. There we go. Now we won't overflow, I think. Okay. Oh! Yeah, okay, it will be equal to 0, so every time we call this, it will just activate. Okay. Well, we keep on creating some windows here, and then we crash. So that definitely didn't work because we set the, well, the handle itself should come from, let's print out the handles. Let's simply print out the handles. I'm curious. I mean, the handle itself should be our label. Oh, we update the window ID, of course. Well, that's the problem. That's the problem. So every time this gets called, we create a new window, which creates a new handle. Okay. So this doesn't work either. So this doesn't work either. Let's close some of this stuff here because we don't need to browse it right now. Okay. Maybe we don't want to clear it here. Okay, we end up creating windows anyway. When we create the handle itself here, well, the problem will be we could do something like this, and the handle probably wouldn't be renewed. Although it's kind of hacky. I mean, the handle probably, well, the handle also gets updated here. At least that's what I think. Let's try to dump the handle. 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 No, the handle is actually the same, it seems. That doesn't change. Well, if I set it back to this window ID. I'm pretty sure it will change. I'm pretty sure it will change. Let's see. It doesn't. Is the handle absolutely the same? Well, the handle is actually the same. Okay. Let's see. Let's see if we get any asserts firing here. We do not. Our handle works. Yeah, we keep on firing this because the handle is set. Well, so that doesn't work. We could set a context uint64 last created window handle and whenever this method here gets done, we will set the past to our handle here and we will do a check if our handle is if well we will allow this to be 0 the first time we enter, so this should be different from this, and then this should be Let's see. If this is 0, and we have a handle, we can call it once. Let's try that instead. Yeah, so now we created it. Created window with handle 1. Yeah. This is a bit hacky. To create a different solution. The handle here is not needed to be set. Oh, great to know, man. How's it going? Let's see. We should probably also set the window position. Oh, that's horrible when you think that you have more time left of the weekend. Oh man, I feel you. That's rough. We could also just ask that this handle was different than the last created handle. Right now it will probably work this same. Yeah. We need to remove this. We don't want that debug information anymore. Okay. Yeah, we need to fix this weirdness, but and then let's add a text afterwards. Blah blah. Well, what was it about? What's your exam test? I don't know why it's bugging like that. It's probably some mouse stuff here. Have we created? No, we haven't. Well, that's because we changed the window, of course. Uh, and record child, yeah. Let's see, p context, or rather, window pointer, current child, win will be our current window. What are the books about? Size. That reminds me of parts of me doing education stuff. Well, good luck anyway. Let's see. No, education is not the most interesting stuff that is. But sometimes you gotta do it. Yeah, I know. Yeah, that sounds like the right way to do it. Uh, yeah, I actually did an exam on the university that way. I think it was a 400-page book or something. I wrote a whole assignment for an exam, and it turned out fine. I wasn't really interested in the subject, so yeah. And I've never used it since, so it didn't matter. Let's see. Yeah, yeah, exactly. uh, Hmm. Okay. Let's see, we create some information here. We also want our thing here to store window creation data is a child. We've created a child. And let's see, a bool child flag. And let's reset this. Also this up here. Let's see, child flag. If p context window creation data child, set that to true. Okay, right now we know that we created a child, so we can do special. Well, yeah, I guess it depends whether you study something that you really like or not. Also, if your education is sort of like uh, well, some kind of craftsmanship or something. Um, no. It also depends on your education system. Sometimes school matter a lot in my country because you might need to get certain grades to advance in the education system. So during those parts of the education system, I find that uh, yeah, well, let's see. Yeah, it does matter, but usually it doesn't. Whoops, I don't do that. I do like this. Let's do a std vector unsigned int window ID stack whenever we create a window p context our window ID here. Let's do the same down here. And whenever we yeah. I feel ya. I feel ya. Okay. So whenever we're done recording on this video, rather window here, we will pop it from our internal stack of IDs, just so that we know that we are done. Okay. So whenever we are done recording anything into our window here, do we even care about this? No. Okay, let's assert that RP context window stack that size and Let's do RP context, window stack, hop back. If our window stack is set, we will set our p context to our current window equal to our p context windows and our p context window stack here, ID stack back. Uh, there we go. Let's try doing that. Okay. Do we get an error somewhere? Is it somewhere inside of here? Let's see, window ID stack size 0. Did we call this before? No. Okay. So our context window ID stack 0. And we haven't. Huh? Let's see, do we ever end up in this place here? No, we don't. Why is that? Record window. Uh, uh, right now, create one, and then create two. Create one. Let's see, list box, record window. Let's disable this for now. Okay, we do not call the second create here. Well, do we ever end up in here? No, we do not. Do we end up in here? No. Oh, that's because we haven't scrolled, yeah. Okay. Mm. Mm. Well, that shouldn't give us a problem, right? Oh, maybe this will give us a problem. Let's try disabling this. Try to call. Vector empty before pop. Okay. If this has any size to it, let's do this. Okay, now we've eliminated that bug. So the blah 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 is written somewhere else. Okay, that does look pretty weird. So the blah 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 is written whenever we create it, but it doesn't know. Well, it's probably because it's written on the child window afterwards, because we don't call and record child window on this p context here. And the end recall child window will just call the context here. We're still getting weirdness all over. Oh, I have to disable or enable that again. Well, our blah blah is just created somewhere else. But let's print this call. Call this. We will never end up in that situation, huh? Why is that? Yeah, maybe it gets confused as to the child window stuff here. It does create window number 2. But it does never call. Well, can we ever end up in a situation where this is valid? No. I mean, also, I don't think this should only be called like that. We should also call it probably in here. Let's see, it's a pointer. Okay, if we just recreate the window, we should of course also add to the stack. Okay, let's see. So, yeah, now we don't get that weird blah 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 bug. Yeah, so it returns to the parent window. Now, we uh, whenever we yeah, what do you call it? Something. Whenever we something. Isn't that nice? Whenever we something, we something. Okay, so whenever we end recording on a window, we pop the window ID out of the stack, and we set the window to the parent of that, potentially, at least the previous window in the current memory, which is pretty good, pretty good, pretty good, pretty good. And otherwise, we will just set our current window as a null pointer here. Let's try that and see if everything crashes and burns. Well. Well, we shouldn't be able to do anything without an active window, so maybe we shouldn't do that, I guess. This puts us in a weird state. The system doesn't have a underlying pointer for referencing. All right. Whatever. Whatever. I like the system where we create a window underneath, no matter what. All right, let's look into the actual setup of our Windows stuff here. So we have right now created a window. Maybe we want the window to store its child flag. Let's set a bool here. Child. And we can simply skip this. The first time we create this, I really think we should delete this, but I'm not ready yet. Child equals the p context window creation data child here. And we will of course do the same down here. Okay. Okay, so we will do some initialization. Eventually, now we can look up a window and add it to the stack. If we don't get a call that's 0 or 1, or rather above 0 or something, we have an error. Okay, so for our first recording during each frame, we set up directs, which are fine for our parent window, but maybe we need different computations for our child window here. Maybe we don't care. Maybe we want to handle that in our situation here, because then after this, our window child window will be our p context current window now, because it's updated. Pointer, of course. There we go. So we could do stuff to our child window afterwards. Let's see, maybe we want to do that. We will have set our handle at creation time. Let's see. Okay. Let's see. We could set our parent window settings inside this, but yeah, I don't think so. Okay. Yeah, yeah, I've been not been active for all 9 hours. By the way, I think I need to. Well, I'll wait a minute. Mm, okay. We on our create here. This is for newly created windows. Let's close these. We're selecting a window. This is for checking if we are in this state here. We set our current frame here so that we don't end up in this situation again. Hmm. Um, let's see. Let's try something out here. GXE assert. Uh, let's try being false, of course, just to check if we can a child with a parent. Let's try that. If am I COVID? What do you mean? Let's see, false won't trigger it, true will. No? True won't. Have I disabled that? Okay. And let's just call throw here. I have disabled the ZP. Oops. The exceptions for some reason. Let's see how many exceptions we get. Let's see. Let's see. Let's see, ID. True will pass. Okay, yeah. There we go. False will not. Yeah. Great. Glad we. Ah, how nice of you. Yeah. If the window here, child, is true, and the window parent is equal to a null pointer. So if we have a child and the parent is equal to a null pointer, we should, no. Let's see. Child false. Parent is this needs to be unlike a null pointer to pass, right? And we shouldn't have a child. When this is 0, it will meaning false, so If window child hidden scope. Let's do this just for debugging because I want to make sure that. Oh, we haven't created that yet. Window index is out of bounds. Oh. And ID is unlike. -1. Let's see. We should probably not do the bounce check anymore. It doesn't make any sense. Hidden scope. Okay, so our window child is true. It has a parent. Uh, let's see. Yeah, you did. It's a 9 out of 10. Uh, no. Why do you ask? If I ever end up in this situation, let's see. So our context here has a series of windows. The first one will not have a parent. The second one will have a parent and be true. And if we access our window here, the parent will be like that. Well, maybe I fill out the wrong address. Because the parent doesn't really, yeah, it's filled with garbage data. So whenever parent, parent window, the current window. Oh yeah, we might reshape the vector actually. That's a good one as well. Oh yeah, the resizing is the problem. The resizing is the problem. So instead of doing that like this, since the pointer might be invalidated, we will handle it inside record window here. We will set our parent here. to our p context Windows that size minus, well, no. We will set it like window nine and a half, definitely. Okay, let's do something like if the window size here is larger than 1, maybe we want the window stack here is larger than 0. We will that's a that's a 5. It's more silly than anything. Okay, let's see the window. Let's see. Do we want front or back here? Because well, we could do something like window stack that one's just nasty. Let's see if we pop the back. Also, let's check if it's larger than 1, because then we can subtract 1 here. Let's add this as well. Okay, let's see. We have our window here, which is a child but doesn't have a parent. That's not great. Well, that's not great. Okay. we can simply instead of passing the parent pointer, we do an unsigned int parent ID, which will be 0 here as per default. And then we will set the p context here, window creation data, parent ID, parent window, ID here. Then we can access our new window, parent equals that size p context last create window data, the parent ID, otherwise we will set it to a null pointer. Right. Oh, reference. There we go. We will do the same thing down here and then, or rather up here. Let's see, we have a window here, which is a child that has a parent. Huh. That has some garbage value. Our window here does have an ID of 1. Did I change this? Well, I apparently have. If window child. Oh well. Oh yeah, we resize the window vector every time, so that's the problem here. Yeah, we need to fix that eventually if we want to support more windows. Fix null pointer in parent calculation stuff after vector resize. Yeah, I'm not gonna bother. I know that this one will be a null pointer and this will be it's close to 10 out of 10. Is this returning an iterator? We will set this after we resize the vector itself. so that at least only when we create new windows. Uh, uh, let's delete that. Why would I end up in a situation where I would have an empty stack? P context, window stack. Is it because? Oh, maybe I made some mistake here. I think I did. Okay, yeah, that's debug. So let's see. Our window here is a child. It doesn't have a parent for some reason. Its ID is 1. That's not great. Let's try this. I shouldn't get an assertion. Well, I do. Let's see. Uh, so this pointer gymnastics here is pretty annoying. Yeah, the underlying vector are kind of like messing up the pointers themselves. Maybe we want to not store the, let's try parent, unsigned int parent ID, which will be 0. Okay. I don't know why we end up in the stack situation because, well, okay. Let's see. New window. Parent ID, which will be actually this should be able to be invalidated. Also the window creation data here -1. P context It will probably be set to 0 though. Yeah, so let's just do 1 because of this memset here. We could change that, but well. Okay. Uh, uh, if it doesn't, and let's unsigned end. P context window creation data parent ID. So this will be 0. Let's delete that. Would we end up in a state where, I mean, this should run. Context, Windows, Windows stack. I mean, how would we actually do that? We place the window ID. Do we end up here often because none some yeah, we end up in that state one time before. Okay. Uh okay, I know why. I know why. I know why. It's because the ID is not that if we have a handle, we can um, search for our handle here. Let's do auto window p context windows if window handle don't we store the handle window parent? No, we don't. No, we don't. We should store our handle. UN64 here. Handle, which will be 0. We can ask for the handle if it's equal to our handle here. We will break, of course. We will set our p context current window here. To our window. Let's do this const. Okay. And then we will set window. Let's do it like this, window, and then we will set our window to our win here. Great stuff. So this should prevent the crash from happening. Let's see. Why do we end up in this state then? Did I mess something up here? Uh, let's see if we disable all of this. Our window is a null pointer. Do we ever end up in this state? State. No, we do not. We do not find. Maybe we don't store our handle. Maybe that's why. There we go. We should end up in our state. Yeah. Okay. We don't want that. We don't want that. We want this. There we go. Okay. Now we do not have any crashes. Let's see. I end up in a Windows state where it's a child and it will have a parent ID which is 0, but we just trust it. And it does have a handle here. The parent pointer hasn't been set, but now we can access its parent. Okay. Oh, whoops. And we don't have those stupid assertions anymore because we fixed the problem. The problem was when we tried to do this by a handle, nothing worked. Yeah, this is not a totally reliable system in terms of all the pointer gymnastics. I think I should optimize on that eventually. So let's see, can we actually, if window child key context window Windows window parent ID uh, let's see. Let's just print out this parent pause, just as a proof of concept that we can actually access this. Yeah, we can. Great stuff. So this will be our check. Okay, let's see. Do we have any special cases here? uh, well, I'm technically not a doctor, But I think you're right. I'll end the stream for today in a short while. I just want to work on this stuff here and try to get closer to being done. Mm. Okay. Let's not clear this here. Let's clear this if we're done setting up, because we will have our window creation data here. We will have our size. Yeah, we need to manipulate this. Let's see. Well, I guess you could discuss whether I'm a doctor. In some countries, my profession would be a doctor. In others, it wouldn't. So, but I don't really care about that. Let's see. Uh, uh, let's see. Well, I'd rather not tell. I want those kinds of that kind of information to stay unclear. Let's see. No, it's not a bad job. I think yeah, I think it's quite all right. Let's see our window size here. Let's do a field here where we bool has size. Uh, then we say here if we p context create window data has size, else we will set it like this. Let's see, equal to the size. Let's okay. That's actually a rect. Oh well. I'm sorry. I can't tell you. Anyway, I'm gonna end the stream for today. Let's see. Whoops. You too, man. Thanks for dropping by and take care and everything. Good luck with your test tomorrow. Yeah. We'll see. But thanks for hanging out. It was really nice to have you here during the day. stay strong and stay healthy. And hopefully I'll see you around, right? All right, take care. Bye-bye.